Good day and welcome to today's class. Today's class is a continuation of our previous classes on JSS3 mathematics. In today's class, we shall be looking at whole numbers. Whole numbers happen to be the first topic under number and numeration. In today's class, we shall be looking at the following themes under whole numbers. We shall be looking at the binary number system. We shall also be looking at using computer to do simple mathematical calculations and how to translate word problems into numerical expression. At the end of this topic, students should be able to 1. Revise basic operations in binary system. Basic operations such as addition, subtraction, multiplication, and division in binary system. You should be able to know how to convert numbers in binary numbers to other bases and vice versa. That is, you should be able to convert from base 2 to base 10 or from base 10 back to base 2 and maybe base 8, base 16 and what have we. We should also know how to solve quantitative aptitude problems on binary number systems. We should be able to use computers to do simple mathematical calculations, and also you should be able to know how to translate word problems into mathematical expressions. So these are some of the objectives we tend to achieve at the end of this topic. Now, under binary number system, this is a continuation of what you did in JSS1. In JSS1, you were introduced into number-based systems and how to count in base 2 and also how to convert from base 2 to base 10. In this class, we shall look in depth into binary number systems. As we learned in JSS1 of this series, counting in groups of 10 is the most commonly used system of counting. When we count in groups of 10, we say counting is done in base 10. In base 10, there are 10 digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That makes it 10 digits. However, certain circumstances often demand the use of other bases. For example, in Nigeria, market days, especially in most rural communities, are counted in groups of 4, 5, or 7 days. In the same way, when counting is done in groups of 2, we say counting is done in base 2. So when you count in group of 3s, we say it is done in base 3. When you count in groups of 4s, we say it is done in base 4. And when it is done in group of 5, we say it is done in base 5, and so on and so forth. So all these are referred to as the various number bases. But for the purpose of this class, we shall be introducing you into the binary number system, which is referred to as the base 2 number system. So I said counting in base 2 is called the binary number system. And numbers in base 2 are called binary numbers. In the binary number system, we have just 2 digits, 0 and 1. When numbers are written in any base, the position of their digits determines their value. Just like what I showed you earlier on, when you count in the base 10 systems, we have 10 digits ranging from 0 to 9. In base 2 system, we have just 2 digits, which are zeros and ones. In base 3 system, we have 0, 1, and 2. In base 4 system, we have 0, 1, 2, and 3 in that order. We said when numbers are written in any base, the position of their digits determines their values. Same thing with base 10. For example, if we have 3627 base 10, 3627 base 10 can be interpreted as 3 thousands, 6 hundreds, 2 tens, and 7 digits. That is why you call it 3627. So these are their place values. 3 is taking the place value of thousands, 6 is taking the place values of 100, 2 is occupying the place value of tens, and 7 the place value of units, of which this can be written in expanded form as, so 3627 in base 10 can be written as 3600 plus 2 tens plus 7 units. And this can be simplified further to be 3000 can now be written as 3 times 1000, 600 can be written as 6 times 100, 2 tens can be written as 2 times 10, and 7 units can be written as 7 times 1. Now, in standard form, as we were taught in JSS2, 1000 can be written in index form as 10 to the power 3, 100 can be written as 10 to the power 2, 10 is written as 10 to the power 1, and 1 is written as 10 to the power 0. Now, all these are written in multiples of 10 because you are dealing with what? Base 10. So in expanded form, this is what you get. In the same way, 1001 base 2 means 1/8, and 8 can be written as 2 to the power 3, 04, and 4 can be written as in base 2 as 2 squared, 02, which 2 can be written as 2 raised to the power 1 in index form, and 1 unit, which 1 can be written as 2 to the power 0. Because remember, we are taught in JSS2 that anything raised to the power 0 is said to be 1. This means that any given binary number can be written in powers of 2 because we are dealing with binary. When we are dealing with base 10 system, we write them in terms of 10. They are grouped in tens, and so on with other bases. Thus, 1001 base 2 can be written in the expanded form as 1001 base 2 is equal to 18 plus 04 plus 02 plus 1 unit. So 8 can be written, 18 is written as 1 times 8, 04 can be written as 0 times 4, 02 can be written as 0 times 2, and 1 unit can be written as 1 times 1. Now, expressing it in index form in multiples of 2, 8 is written as 2 to the power 3, 4 is written as 2 to the power 2, 2 is written as 2 to the power 1, and 1 is written as 2 to the power 0. So we must always indicate which number base we are dealing with. This is done by putting the base number as a subscript to the given number. For example, 568 base 5 is written like this, where 568 is said to be the given number, and 5 written in words is said to be the base number. So the base number is always written as a subscript to the given number. So this is how you represent number in a given base. Also, if you have 3127 in base 10, this is how it is written. Or if you want to write this in base 10, this can also be written as 568 in base 10. Although this cannot be in base 10 because 8 is not a digit in base 10, but this is just an illustration to guide us. So let's take some examples. In example 1, we are asked to expand the following numbers in the powers of their bases. So this is given in terms of base 2, 1100001 base 2. So you need to know their place values. This is written in terms of 2 raised to the power 0. This is written in 2 raised to the power 1. This is taking the place value of 2 raised to the power 2. This is taking the place value of 2 raised to the power 3, 2 raised to the power 4, and 2 raised to the power 5. So in expanding this, what you will do is to pick the number times the value of the place number, which is 2 raised to the power. You start from your left. This is occupying the place value of 2 raised to the power 5. So it's said to be 1 times 2 raised to the power 5 plus, you pick the second, 1 times 2 raised to the power 4 plus 0 times 2 raised to the power 3 plus 0 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. So this is how this can be expressed in expanded form in its base. Remember, it's going to be the place value of the base. Example 2, 432 base 5. This is taking the place value of 0, 1, and 2. So this can be written as 4 times 5 raised to the power of 2. Remember, this is the place value 5 as against 2 because we are working with base 5 plus 3 times 5 raised to the power of 1 plus 2 times 5 raised to the power of 0. C, in expanded form, C can be written as, this is in base 10, so this will give us 3 times 10 raised to the power of, what is the place value? This is 0, 1, 2, 3. Or, in essence, you can say this is 3 times 10 raised to the power of the number of digits you have after that value. So I have 3 digits after 3. So this is going to be times 10 raised to the power of 3. If you cannot write the place values from 0 upwards, you can just count the number of digits after that number, and that gives you the place value. So this is 3 times 10 raised to the power of 3 plus, pick the second number, which is 2 times 10 raised to the power of, how many digits do I have after it is 2 plus 5 times 10 raised to the power of 1 plus 6 times 10 raised to the power of 0. So this is how you can express numbers in number-based systems in expanded form. That brings us to the end of today's class. In today's class, we have learned how to express numbers in their number-based systems in expanded form. Before we end the class, let me leave you with an assignment. I would like you to expand the following numbers in the powers of their bases. All you need to do is to repeat what I have done. Okay, so just to write this in expanded form in terms of base 2. Number 2, you also do same in terms of base 2. Number 3 is 3, 3, 4, 9 base 10. Number 4 is 7, 4, 6 base 8. Number 5 is 3, 2, 1, 0, 1, 1 base 4. And we have number 6, which is 1, 0, 1, 0, 1, 0 in base 2. Number 7 is 5, 2, 2, 0, 4 base 6. Number 8, we have 2, 3, 8 base 9. And number 9, 4, 0, 1, 2 base 5. Number 10, we have 1, 0, 1, 1, 0, 1, 1, 1 base 2. Number 11, 606 base 7. Number 12, 1124 base 5. Number 13, 35 base 10. Number 14, 100011 base 2. Number 15, I have 110111 base 2. Number 16 is 124 base 16. Number 17, 607 base 9. Number 18, 11021 base 3. Number 19 is 35 base 7. And number 20 is 35 base 6. This is to help you master how to expand numbers in the powers of their bases. Kindly like our videos as you watch, while we recommend that you subscribe to our channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can use the comment section to interact with me on areas that are still difficult for you to understand. You can also share the link with your friends and family so that they can also benefit from this class. You can follow us on all our social media platforms at My Lesson Teacher, on Facebook, on TikTok, and on Instagram. Thank you and do have a nice day. See you in our next class. Note that for the first 5 students to give the correct answers in the comment section, you are entitled to a 1,000 Naira recharge card of any network of your choice. Do have a nice day and see you in our next class.